Okay, let's talk about section 2.3, hydraulic pressure. First, before we even get into this, I want to remind you we already learned hydraulic pressure at the very beginning of the year. We were talking about mix and flow of matter. That first unit, we talk about fluids and how fluids exert pressure equally in all directions, Pascal's law. This is the exact same. It's the same formula, it's the same type of questions, and it's the same process to finish the questions. So keep that in mind. Try to remember learning this before. It was a while ago, but we have done it. So let's get going. So first, a hydraulic system is a liquid under pressure and it moves a load. Hydraulics increase the mechanical advantage of a simple machine by using that larger system. So that's just saying hydraulic systems have a very high mechanical advantage. Right? You might have a mechanical advantage of 5 with a lever, but you could have a mechanical advantage of 50, 500 even with a hydraulic system. So hydraulic systems are all around us, really. That backhoe in the picture is a hydraulic lever, right? It's a hydraulic system in a lever. The common question when we're talking about hydraulic lifts is a car lift, because it's got a very straightforward input and output. So let's look at that. So our formula for pressure. So pressure is force divided by area. And yes, it is on your formula sheet. The unit for pressure is the Pascal. Right, so force you'd measure in newtons, meters would be, area is meters squared, and the pressure is a Pascal, a PA. All right, let's start with a simple, straightforward question on pressure. So if you have a force of 10 newtons over an area of 2 meters squared, what is the pressure? All right, so we're starting our math. Notebooks open, pencils out. Let's do these together. Again, math, not a spectator sport. You learn by doing it. So let's do this together. All right, so let's look at this question to get us going. So the pressure is force over area. They gave me the force, they gave me the area. Let's just find the pressure. So my force is 10 newtons divided by my 2 meters squared area. Ten divided by 2 is 5. Now my units is pascals. So the pressure in this system would be 5 pascals. So Pascal's law. Pascal's law states that pressure applied to an enclosed fluid is transmitted equally in all directions throughout the fluid. This is important, and this is going to lead to a bit of a shortcut that I'm going to show you in a second. So pressure is the same. That means pressure here, pressure, not force, not area, but the pressure in the input piston will be the same as the pressure in the output system, the force per area. So your input piston will often be a smaller area. It'll be smaller. It'll have less resistance. And then your output piston has even a larger area with then more of a force available, but the pressure is the same. That ratio is the same of force to area. All right, watch the video in your own time. So the mechanical advantage from pressure comes from the fluid under pressure. Remember, the force applied to the input piston creates a pressure in the fluid. It squeezes the fluid. The pressure then transfers throughout the enclosed fluid and will press on the output piston, creating a force on the output piston. So the forces, input and output, are not the same. That's the point. We want this large mechanical advantage, but the pressure is the same. So let's give this one. So let's practice this question. So let's calculate the mechanical advantage. They give us the force input is 20 newtons, the force output is 500 newtons. What is the mechanical advantage? All right, so let's look at this first practice question for mechanical advantage. So I'm going to draw the picture, and I would suggest you draw it too. So let's give this a draw. So the small side is always going to be the input side. So my force in is 20 newtons. And my force output on the bigger side is 500 newtons. There you go. Now I can keep it separate and together. This is especially important when they start adding in information about areas and pressure, etc., etc. So this is a straight, what is the mechanical advantage of the system question? It's a good place to start, but also know they will give you hydraulic systems and not ask you about pressure. So don't go right into your pressure formula. This one is mechanical advantage. So mechanical advantage is force out over force in. So it is my output 500 newtons divided by my input 20 newtons. So my mechanical advantage is 25. That's all you need to do for that question. Okay, so again, don't go straight into a pressure formula calculation. All right, so I added a couple practice questions to help you get the swing of things. So let's look at this one here. So if a force F1 is 100 newtons is applied on the left of a hydraulic lift, where area 1 is 0.02 meters squared, area 2 is 0.08 meters squared, what is the force that will be produced? So this is often a very common question you see with hydraulic pressure. There are lots of numbers here, and it can be confusing, but it doesn't need to be. So I'm going to show you a bit of a trick here. So stay with me and do it with me. Open your binders, paper out. Let's do this together. Okay, let's look at this next question. Right, so this one again, let's draw our picture. So again, I have my input piston and my output piston. They grouped it in the picture there, and also my A1 and my F1 will go together, my F2, my A2 go together. They are using 1s and 2s. Our formula is looking for inputs and outputs. So the 1 is our input. We know that because it is the smaller tube and the smaller force, or the smaller area. So we know pressure is equal in this system, right? That is Pascal's law. Pressure 1 will equal pressure 2. Okay, but I don't know pressure. There's a hard way and an easy way to do this. I'm going to show you the easy way. Don't worry about the hard way. Don't do the hard way. It's harder. There's more places for you to mess up. So pressure, what was my formula for pressure again? Pressure is force divided by area. So the pressure on the input side, the 1, is the force 1 divided by area 1. And that's going to be equal to pressure 2, or the output pressure on this side of the system. So that will be force 2 divided by area 2. Okay, now let's fill in from our formulas. Force 1, 100 newtons, divided by 0.02 meters squared equals, we don't know, that force 2 divided by 0.08 meters squared. So now I ask, we have two fractions that are equaling each other, and I have one unknown. Can I solve this? Absolutely I can. I can do it in two ways. I can cross multiply. So I can cross multiply and go like this. Or I can do equal fractions. I like to do equal fractions, so I'm going to continue doing my equal fractions. If you have a question about cross multiplication or you like it more, keep doing that. But again, I'm going the easiest way all the way through. So I'm going to do equal fractions. So equivalent fractions. So I'm just going to go to the next page to give myself some more space here. So equivalent fractions is going to ask me, how do I get from fraction 1, how do I get from here to here? And then I'm going to do the same thing here to here. So our areas are in decimal form, right? 0.02, 0.08. Don't let that intimidate you, right? You're going to get areas that are decimals a lot because will be rare. Like 1 meter square is a very large area, right? That's like 4 meter sticks together, right? That's a huge chunk. And we're often looking at inputs, outputs that are, centimeters squared. So that's why you have that decimal. Don't let it intimidate you. It is the same process. So if I had just this 8 and just this 2, what do I multiply 2 by to get to 8? What do I do if I get 8 divided by 2? What's that answer? That will give me 4. If I add in my decimals, again, that doesn't change it. 0.08 divided by 0.02, that is still 4. That works out. So that means from 0.02, I need to times by 4 to get 0.08, right? 2 times 4 equals 8. Now these are equal fractions. Whatever I do to the bottom, I need to do to the top. Whatever I do to the top, I need to do to the bottom. So that means I need to also multiply the top times 4. So what is 100 newtons times 4? You got it, 400 newtons. So my force on the output piston is 400 newtons. All right, let's run through this one more time. So back to the beginning. Because pressure is the same, that is very important. The pressure here equals the pressure here. That is Pascal's law. That is why we measure pressure in pascals. Pascal's law says pressure here is the same as pressure there, which is what I have in this step and this step as well. I just substituted in the formula for pressure, which is force divided by area. Then I was able to get to my equal fractions where I can cross multiply or do my equivalent fraction work, which led me to find that the force is 400 newtons because we are multiplying by 4. That is how we get our equal fraction. All right, let's look at this practice question. This one's laid out like a test. If in a hydraulic lift, one of the areas is 3 times larger than the other, and a force of 15 newtons is applied to the smaller area, what is the force that will be on the larger area? All right, think about that one for a second, especially considering the question that we just did. Then we'll look at this together. Okay, so this one's a little different because it doesn't give you all of the information. So the force input is 15 newtons. Force output we want to know, and the areas, they don't give us the actual numbers, but they give us the relationship between the two numbers. And remember, pressure is equal. Pressure in equals pressure out. So that's how I'm going to start. So my force in is 15, and my area in, force out, area out. So if you go through this in this step as I had, you might get stuck with this, 15 newtons, and then a whole bunch of unknowns, equals I don't know. They're both divided by things that you don't know. All right. This area in, this area out. All right. Now what did they tell us about area? One area is 3 times larger than the other area. This is times 3. And I don't know if it's 2 and 6 or if it's decimals, or I don't know. I don't know what it is. It doesn't matter. They told us what we need to know. We need to multiply it by 3. Right? I know area output is the larger area because it always is the larger area. And I don't get to say always very often, but this is always the largest area. So what I do on the top, I do on the bottom. What I do on the bottom, I do to the top. So 15 times 3 will give us that force output. So 15 times 3 is 45 newtons. There you go. So this question may have looked challenging, but it's actually some of the quickest work that we've done this whole section. Right, so again, write down what you know, what you need to know, do your formulas, and keep thinking, how do these two sides relate together? because the input pressure is the output pressure. And that's going to save you a lot of times. So use that fact. All right, then that's it for pressure. If you have questions, ask your teacher. Do your practice questions, and remember as well that additional Section 2 review worksheet as well. Okay. Thanks for watching. Have a good day.